Good morning, students. We'll continue that previous class. So here in that previous class, I was saying about this one, refraction of light through a parallel-sided glass slab. So now look here. Here AB is an incident light ray for this surface 1. Now BC is a refracted light ray for this one. Refracted. So now you concentrate. I1 is the angle of incidence at surface 1. What about R1? Here I mentioned R1, angle of refraction. Angle of refraction at surface 1. I mean with respect to surface 1. So three angles there. I1, R1, delta 1. Delta 1 is what? Delta, you look here. Delta, what the delta telling? This incident light AB, instead of going straight due to the presence of glass medium, it moved along BC. Instead of going straight, it moved along BC. Means what? It deviated. It changed their path. How much? Delta 1. That we call as angle of deviation. That much it bent. Alright. Just now you see here. Now that light BC propagating through this glass medium, and now when it comes here, look here, when it comes here, what happening? That BC light ray changing the medium. That BC right now in which medium? Glass medium. When it comes at point C, there which medium is there? Air is there. Here glass there, it changing. I mean this is interface. Obviously again which phenomena is taking? Refraction is taking. Now you concentrate. BC light is incident light ray for this second surface. Incident light ray. BC is incident for this one. So yes, to this point of incidence, again as I said, you must and should draw one perpendicular line. You see, this blue colored dotted line is normal to this point of incidence. Yes. Now this I2 is the angle of incidence with respect to this side surface, I mean second surface. This is angle of incidence. Now concentrate. Light moving from glass to air. Mean it is moving from denser medium to rarer medium. When light moving from denser to rarer, it is bending away from the normal. Away from the normal. That's why you see here this light ray, this BC light, instead of moving straight along this dotted line, it keeps moving away from the normal. Normal is here. This CD light, CD bent away from the normal. That CD light is refracted light ray for this second surface. Refracted. It moved away from the normal because the speed in that rarer medium got increased. That's why that bent away from the normal. See here, light which is entering into this parallel sided glass slab suffered two refractions. One refraction at first surface, another refraction at second surface. I mean that light deviated two times. Here at first surface it deviated, it changed their path by delta 1. It bent inward. It bent inward by delta 1. Now instead of going this BC light, concentrate on this BC. Instead of going straight, it bent outward by how much angle? By delta 2 angle. You see, look on this delta 2. Delta 2 is the angle of deviation at second surface. Instead of going straight, it bent this much. So delta 2 is deviation at second surface. Now very important. This CD is a emergent light ray. Emergent means what? A light which is coming out from that glass medium. This is final light ray. Came from glass slab. AB is light which entered into glass, and CD is the light which came from the glass slab. Now you just look here what I mean to say. How much this AB bent inward in the glass due to refraction at phase 1. How much it bent inward? Same amount it bending in outward direction. Look here. How much it bent inward? Instead of going straight, it bent inward. How much it bent inward? With the same amount it bending outward. I mean delta 1 and delta 2 are same. The light which entering into a parallel glass slab surrounded by a homogeneous medium suffering equal deviations but in opposite direction. Equal deviations but in opposite. What it opposite? Equal means what? How much it will bend inward. I mean here bending is towards the normal, so we call it as inward bending. Here bending is outward. Instead going like this, it bent away from the normal, so we call it as outward bending. How much it bent inward? Here at first surface, same amount it bent at second surface but in opposite, mean it bent outward. So delta 1 and delta 2 are same because of this equal amount of bending in opposite direction. That final emergent light ray CD looking parallel to the initial direction of incident light ray. Look here. Which is incident light ray? AB. AB is incident light ray. You extend. Suppose glass not there means what? Glass slab not there means that AB keeps moving along this dotted line. I mean this dotted line is the initial direction of incident light AB. To this initial direction, that final emergent light ray, final emergent light CD looking parallel. Why it is looking parallel? Because of suffering equal but opposite deviation. Getting what I mean to say? Here inward, how much it bent? Same amount it will bend outward. Obviously, that being parallel. See, this is going to happen only when that glass slab surrounded by homogeneous medium. Suppose if it is not surrounded by homogeneous means, then this emergent light ray is not being parallel to that. How? That you see here. Suppose here air is there. Air to glass. Bending is different. Suppose glass to water there. This side water there. Obviously, when light coming from glass to water, that amount of change in speed is different what it was here. That's why how much it bent inward, there it not going to get bending with the same amount. That's why I said to get this lateral shift, to get this one, that medium must and should surrounded by the homogeneous medium. How much bending going to happen here? Same bending going to happen there, because same medium, air to glass, glass to air. Here inward bending, there outward bending. So we mentioned that it has to be surrounded by homogeneous medium. This is the phenomena we observed. Finally, See here, lateral, we call this title as lateral shift. Lateral shift means what? Shifted by side. Shifted by side means what? You just look here. AB is incident light. This is incident light. What is CD? CD is emergent. CD is a light coming out from the glass slab. AB is entering. How they look? So you just look here. This is incident path. This is emergent path. How they shifted? Laterally. This final light coming from glass slab shifted side. So it shifted parallelly. So we call this shifting as lateral shift. Have you understood why we call as lateral shifting? They same. I mean they being parallel only. Just it shifted side. Okay? Yes. So now this is explanation about how it taking place. In exam, they will be asking define lateral shift. At that time, just you have to write the definition for this lateral shift. See now you see here what I mean to say. The perpendicular distance between the emergent light ray and the initial direction of the incident light ray. The perpendicular distance between the emergent light ray and the direction of incident light ray. And the direction of incident light ray is called as lateral shift. Have you understood what means lateral shift? It means that light is going to just shift by side, so we called it as a lateral shift. Here I mentioned delta 1 is equal to delta 2. Very interesting. Why it shifted parallelly? Simple. How much bent inward at first surface? Same. With the same amount it bent in outward direction. Firstly it bent inward and finally there it going to bend outward. That's why emergent light ray and incident light ray are looking parallel. This is called as a lateral shifting. Yes. After this one more is there that we call as a normal shift. Normal shift. There are two observations there. One is normal weave, another is oblique weave. What it means? That only previously I said. What you just see here. What I was saying. Take one container and keep a coin in it and put the water and weave it normally. What you see there, that coin appears to came up. It looking like came up. Okay, that shifting that was being at the bottom, but for you, how it looking? It came up. This is because of refraction of light. If you look that like this is water container, this is the glass container. I mean glass container. In that you just place one coin and you pour the water. Now you weaving that one with two positions. If you weave like this along the normal line to that water surface, this is container, top surface is there. This is normal. Along this line, if you weave like this is called as normal weave. Are you getting what means normal weave? Oblique weave means what? This is normal line. If you weave that one like this, container is here. If you weave like this, at that time also, that coin looking came up. At that time also, you seeing there that coin is at upward position. It shifted up even by weaving by side. This side we call as oblique weave. I said oblique means in previous class, not along parallel, not along perpendicular. That called as oblique weave. So here, why that coin or why that object placed in that water medium and viewed by another medium normally or even obliquely appears to came up. Why that coin is looking being at the upper position? That is because of refraction of light. That one only we are trying to understand with a diagram, with a ray concept. See now, look on this first one, normal beam. See here, this is a container. You see here, this is a container. Getting what I mean to say? Now you see, in this container, you may treat it as a water container, or even you may treat this as a glass also, parallel sided glass. If you take a glass and below that glass, if you put a coin and if you weave, that coin looking up. Getting what I mean to say? Yes. So now you see here, this is a container, water container only. You imagine like water container. Okay. This is water. Above water, air is there. This is medium, air medium. This is water medium. Now here this is object. You kept that object in that water medium. Okay? Object is in water medium. Now what you doing? You weaving that object. How? Normally here I have drawn. This is eye, observer eye. See the position of that eye. This is the surface, water surface. So this water surface, this is which line? Normal line. Along that normal you weaving. So it is called as normal weave, like this. To this surface you weaving like this. This is normal weave. What will happen at that? You see. This is water container. Inside that at the bottom you place the object like a coin and weaving like this. What happening there? You see. I have taken 3 light rays. First you concentrate on this light ray. This one. A light ray. This light. Okay. On this one. This light ray. It's coming. I am going to change their medium at this point. A light coming like this. It's going to hit that interface. This is the interface. I mean, interface means what? A line or a surface which is going to separate 2 medium. Above this line, air is there. Below that line, water is there. So this is interface. To that interface, this light ray got hit by normally. Normally means perpendicularly it came perpendicularly. Now a light which is going to change the medium normally is not suffering any deviation. It keeps moving along their respective path only. That's why this light ray is moving straight. This light ray, it moved straight because it is normal incidence. It is normal incidence, so it keeps moving along that respective path only. Yes, it received by that observer. This light ray got received by the observer. Now you see here, one more light ray is there. This one. Now we concentrate on this one. Yes, this light ray is coming, and it got incident here. See, this is incident point. Here now. To that incident point, you must and should draw normal. See this blue colored line. This blue colored line is a perpendicular line to this point. So that's why this is what? Normal. This is normal. Getting? Yes. A light ray from this object coming like this and it going to hit here. I am going to change the medium. It is coming from which medium? Water. This is water. Okay. Water medium. Water to air. Mean among these, which one is rarer? Air is rarer. Water is denser. Light ray moving from denser medium to rarer medium. Obviously, it bending away from the normal. You see here, this light ray This light ray came and it got incident here, changing the medium. So now it moving from denser to rarer means it bending away. Instead of going straight, instead of going like this straight, it bent away from the normal. This is normal. It bent away from the normal. This is a light, a refracted light. This is first refracted light and this is second refracted light. This one is first incident light and this is second incident light. Getting what I mean to say? Yes. This bent away. Yes. Here, this light ray also is going to received by the observer. This light ray also going to received by the observer. Mean it is entering into the observer eye. Two light rays. Then look on one more light ray. This one, third one. This is third light ray which is coming from that object. Yes. This light ray is coming like this. And it got incident here. See, it got incident here. To that point of incidence, again you have to draw one normal. Here I have drawn. This blue colored line is the normal to this point of incidence or to this interface. So now also that light ray third is moving from denser medium to rarer medium. So it is bending away from the normal. See, this light ray, instead of going straight like this, instead of going straight, because of change in medium from denser to rarer, it bent away from the normal. This is normal. See here, it bent away from the normal. So this is third refracted light ray. How many refracted I have taken? 3 refracted. These 3, how they looking? You just look on these third and 2. You just look on second refracted and third refracted. They looking like diverging. Obviously, they looking like this. This is third and this is second. They looking diverging. You are here, you are observing somewhere. Yes, you take them back. Diverging beam obviously coming out from one common point. When you extend those second and third light ray back, somewhere they are going to get meet. Where they are going to meet while taking them in backward direction, there we are going to see the image. There we are going to see the image of this object you see here. You just extend this third refracted light ray in backward direction. Yes, I extended here like this. Yes, extended. And even you extend this second refracted light ray also. You extend it back. Yes, you see here. Extended. Yes. And even this is first one. It came like this. I mean, by extending second and third refracted light ray in backward direction, they met here. Where they met, there they produced the image of that object. The image of this object produced here, that I have written I is image. For you, when these 3 light rays are received by your eye, for you, this object is being here. It looks being here. Obviously, in first class only I said. Re-emitted, I mean emitted light rays from any object, when they are going to enter into our retina, they are going to produce the sensation of presence of that object. See here, when these 3 light rays are received by you, then you feel the presence of that object, where not here. You feel, to you, these 3 light rays are looking like coming from this position. That's why there you will be seeing the image of this object. Yes, you see here, there is a shifting in the position of that object from here to here. For you, that object is looking like being here. That's why I said when you weaving that coin through that water, like normally you feel that coin came up. Actually, that was being at the bottom only. Coin was being at the bottom of the container only. But for you, that looking like came up. This shifting along that normal line called as normal shift. That coin shifted along that normal line because of refraction of light. This we call as a normal shift. Have you understood why it is going to look like came up? It looking only. That's why we calling it as apparent position of the object. Apparent position. For you, it looking like as being there, but in reality, it is not being there. In reality, that being here only, at the bottom only. It appearing like that, being there. So we call it as apparent position. Apparent position. This is apparent position with respect to your eye. This is the real position. This is the real position. This is appearing position. So that's why two words here we are using: real depth and apparent depth. Real depth here from the top, from that interface where exactly that object is there, that we call as real depth. From that interface where that object is there actually, that we call as real depth. That I have mentioned, from interface to that bottom. This is the real depth. Appearing depth, apparent depth. But for you, it looking like being here. For you, it looking like is being here. Then this depth we call as apparent depth, looking depth, not real depth. It looking, that object is here. So this depth we call as apparent depth. Have you understood this? This is apparent depth and this is real depth. Yes. No. If they ask define normal shift, then you have to write the definition. See that. Normal shift means what? See here. The apparent shift in the position of object placed in one medium, and viewed along the normal by another medium is called as normal shift. The apparent shift in the position of an object placed in one medium, and viewed along the normal by another medium is called as normal shift. Getting what it means? We place the object in water and we seeing that by being in another medium. By being in air, you observing that one. Getting what I mean to say? That only try to get the apparent shift in the position of an object placed in one medium and viewed along the normal line by another medium is called as normal shift. Because of this normal shift, that what I said, that coin is being like appears to came up. Then this is normal view. Then here it is oblique view. Oblique view means you just same analysis only. Here you viewed like this, that your eye is along normal line. Here it is oblique view. Oblique, I already said. You weaving like this by side. You see here. You are observing here. Now concentrate. Same analysis. Same. Here it is again water medium. In that water medium, you place the object at its bottom. Okay. Now you weaving. See here. Now here oblique weave is there. Oblique means already I said you weaving like this type, not along that perpendicular line. Same analysis there. You kept that object in that water medium only. Okay. From that object, light rays are coming, and here they getting refracting, and finally they going to receive by your eye. What exactly happening here? You just look here on this diagram. See, it's an object. From that, I am going to take two light rays. See here, it's a first light ray. This is first light ray. This light ray is coming through this denser medium, through this water medium, and here it's going to change the medium. At this point, this light ray, it came, got incident here at this point, and here it is going to change the medium from water to air. So now to that point, we have to draw the normal. This blue colored line indicating the normal to that point. Again, here light moving from denser medium to rarer medium, that's why it is going to bend away from the normal. This is normal. Instead of going straight, it bent away from the normal. This is the refracted light ray which is going to received by your eye. Then take one more light ray. This is a second light ray coming from that object. Again it is coming through that water medium. It is going to strike the interface at this point. Again there you have to draw one normal. So now you see again light moving from denser to rarer, it is going to bend away from the normal. Instead of going like this, it bending away from the normal. See here, this is a first refracted ray and this is second refracted ray. These two light rays, they looking like diverging. So these two light rays, when they go and incident on your eye lens, there you will be feeling their presence. Means what? These two light rays looking like coming from one object. From one particular position. See here. These two are diverging. So you extend them back in direction. You extend this first light ray in backward direction and extend that second refracted light ray in backward direction. Somewhere here they are going to meet. There, where they are going to meet, they are going to produce the image. These two refracted light rays looking like came from this position. Came from this one. So that's why your eye feeling this object is here. That your eye feeling this object is being here. Why? Because these received light rays are coming from this position. That's why there you will be seeing the image of this object. That's why when you view like this obliquely, even that object which placed at the bottom in that water medium appears to looking like came up, appears to shifted in upward direction. That we call as a apparent shift. Again here same analysis. This is called as this one. This total from top surface to bottom, that we call as a real depth of that medium. Real depth, and this we call as apparent depth. That object, it looks like being there. It looks like being there. So from this position we feeling that object is being there, we feeling it is being there. So that's why again this is going to happen because of refraction of light.